Mods 1 and 2, quiz 2.2 to 2.4, derivative rules. Number 1, find the second derivative of this function. So looking at x for the chain rule, x is being multiplied by 3. Then we're taking the cotangent of that function. So y prime, deriving from the outside in, derivative of cotangent is negative cosecant squared of the function times the derivative of 3x, which is 3. So negative 3 cosecant squared of 3x. I'm going to rewrite that function as negative 3 times the quantity of cosecant 3x squared. When the exponent's between the trig function and the expression, the whole thing is being squared. Now for the second derivative, looking at x for the chain, x is being multiplied by 3. We're taking the cosecant of the function, and then we're squaring the whole thing. Now this first negative 3 is just a coefficient, so we're just going to multiply the derivative by negative 3. So working from the outside in, the derivative of something being squared is 2 times that something to the first power. The derivative of cosecant is negative cosecant cotangent. And then the derivative of 3 times x, we would just have to multiply this whole thing by another 3. Alright, so y double prime, negative 3 times 2 is negative 6, times negative 1 is positive 6, times 3 would give us a positive 18. Then we have cosecant squared of 3x, because 2 cosecant of 3x's are being multiplied, and then multiply that by cotangent of 3x. Find the equation of the line tangent to the graph at this function. So equation of a line, we'll use our point slope form. The slope comes from the derivative of the function. So using the same technique as number 1, I'm going to rewrite the function as secant of pi x, all squared. So looking at x is being multiplied by pi. We're taking the secant of that, and then we're squaring the function. So the derivative, working from the inside out, would be 2 times secant of pi x to the first power. Derivative of secant is secant of the function, tangent of the function, and then the derivative of pi times x is pi. So to get the slope of the tangent line, now we have to evaluate the derivative at 1/4. So we have 2 pi secant of pi times 1/4 squared, and then tangent of pi times 1/4. So now evaluating the derivative, 2 pi, secant is the reciprocal of the cosine function, so cosine of pi over 4 is square root of 2 over 2. So we take the reciprocal of that. Tangent of pi over 4 is 1. So we have 2 pi times 4 over 2. So our derivative is 4 pi. Plugging the information in, y minus 2 is equal to 4 pi x minus 1/4. So y is the product of the functions u and v. So to find the derivative, we need the product rule. First times the derivative of the second function plus second function times the derivative of the first function. So now to evaluate y prime at 1, we find, or we're given the value of these functions. So we have 2, this should be a times, not a plus. So 2 times the derivative of v is 1, plus v of 1 is negative 1, u prime of 1 is 2. So 2 minus 2, y prime of 1 would be equal to 0. Alright, that's not the answer I got on the test. U times v prime of 1. So u of 1 is 2, v prime of 1 is 1, v of 1 is negative 1. Okay. So u of 1, 2 times 1 plus negative 1, and then u prime of 1 is 3, not 2. So 2 minus 3, negative 1 would be y prime of 1. So negative 1 is the correct answer. A particle moves along a line so that its position at any time is given by this function. Find the velocity. Okay, so the velocity is the first derivative of the position function. We don't need the quotient rule for the s of t because there's no variable in the numerator. So if I rewrite the position function with a negative exponent, the velocity is the derivative of this function. So using the power rule, bring the exponent down, subtract 1 from the original, negative 2 times t minus 6 to the negative third power. So my velocity function, using positive exponents, negative 2 times t minus 6 to the positive third power. Now the acceleration is the derivative of the velocity function. So I'm going to use the power rule. So the acceleration multiplied by negative 3 from our velocity function, which is our exponent, subtract 1 from the original exponent. So the acceleration function would be positive 6 over t minus 6 to the positive fourth power. So 1 fraction positive exponents. Find the point on the function where a horizontal tangent line to the graph of the function exists. Okay, horizontal tangent line. That's where the derivative equals 0. So the derivative of this function does need the quotient rule. Bottom times the derivative of the top minus the top function times the derivative of the bottom, all over bottom squared. Distributing the 2x, we get 2x squared minus 2x minus x squared, all over bottom squared. Remember, we want to simplify as much algebraically before moving on. So this is our derivative. Now when we set the derivative to 0, a rational expression is equal to 0 when the numerator is equal to 0. Factoring out an x minus 2 times x. So x is equal to 0 and x is equal to 2. Now to answer the question, we need to find the point on the function. So take these values that made the derivative 0 and plug them back into the original. So f of 0 gives us a y coordinate of 0. So 0, 0 is where a horizontal tangent line occurs. Plugging 2 into the function. So when x is equal to 2, y is equal to 4. So both of these points need to be included for full credit. They're where the tangent line to the function would have a slope of 0. All right, find this derivative using the product rule. We'll rewrite this so that the 2 minus x squared, we can see that raised to the 1/2 power. So now first times the derivative of the second. Now the second term needs the chain rule. Because if we look at x is being squared, and then we're raising that function to the 1/2 power. So first times the derivative of the second, plus second times the derivative of the first function. Derivative of x is just 1. Okay, these 2's will cancel each other out, multiplying and making positive exponents. I get x times negative x is my negative x squared. Make this exponent positive by moving it to the denominator. And then my second term, the exponent's already positive. All right, so 1 fraction, positive exponents. Our common denominator here would be 2 square root of 2 minus x squared. So to get the common denominator, the first fraction does not need anything done to it. So we keep that as negative x squared. We multiply the second function by square root of 2 minus x squared on the top and bottom. No negatives need to be distributed. Now just combining like terms, we get 2 minus 2x squared all over the square root of 2 minus x squared. So that would be the most simplified answer. Lastly, find the derivative of this function. This is not product rule because there's only one x here. So the only thing we can do, the cosine x is being raised to the 1/3 power, so that's important to see for the chain rule. So now when we look at x, we're taking the cosine of x, we're raising that function to the 1/3 power, and then we're taking the tangent of that entire expression. So for the derivative, we work from the outside in. The derivative of the tangent function is secant squared. We can only derive one function at a time. So we were taking the tangent of the cube root of the cosine of x. Derive tangent. Now how do we derive something to the 1/3 power? Bring the exponent down front. And then subtract 1 from the exponent. So we derive that function. Now the derivative of cosine is negative sine x. One function, positive exponents. My denominator now will be the 3 from the 1/3. And then cosine x to the positive 2/3. 1/3 minus 3/3 would give us negative 2/3. So this whole expression needs to be brought to the denominator. And we have negative sine x secant squared of the cube root of cosine of x.